Hello everybody, this is Lalita for Mushrooms on Mars. So, we finished the first episode, this is the second one. We haven't actually come to the mushrooms part or the Mars part. We're still speaking about space ag, growing food in space. So, in the previous episode, we spoke about the need for growing food in space in very hostile, constrained circumstances. Now, in this episode, we are going to talk specifically about the plant growth systems on ISS. ISS is International Space Station. So they have been doing a lot of experiments, and now because of that, we know how plants actually grow in space based on the experiments done on the ISS. So there are multiple plant growth systems that they've tested, and we have found out a lot of things about microgravity, about gravitropism, and plant growth patterns, and what are the resources needed, right? So we're going to do a deep dive into the plant growth systems for space ag, and especially on the ISS. So the plant growth systems on the ISS are the reason why we can actually understand how plants can adjust or how they react in microgravity environments. And is it even possible for us to grow food to support long duration space missions? You know, it can go on for years or months, and we can't pack everything and bring freeze-dried food for everybody in the spacecraft. So these are systems that have been designed to provide plants with essential elements that they need to grow, like light, water, air, nutrients, and of course all the rest of the challenges, especially the absence of gravity. So let's do a deep dive. The material, I'm going to put it up on the website. You can find it on jelliclesfarm.com, and under it, there will be Mushrooms on Mars. And I'm going to get the material up there if you want to do a deep dive of your own. So, onwards.
Picture this. You're an astronaut, millions of miles away from Earth, gazing out at the stars. And suddenly, you have this, craving for a fresh salad.
A salad.
Yeah. Sounds a little impossible, right?
A little.
But that's actually the kind of challenge that we are diving into today in this deep dive that was specifically requested, by the way.
Oh, wow.
Yeah, we're talking space gardens, how astronauts actually grow fresh food in the incredible zero-gravity environment of space.
And it is about so much more than just satisfying a craving, which, don't get me wrong, that's important. But these space gardens are really pushing the boundaries of what's possible in agriculture.
Totally.
In space and here on Earth.
Okay, so let's unpack these space gardens. We've got a whole lineup of systems to explore today. Veggie, APH, BPS, LADA, and bioculture. Where do we even begin?
Well, I think it's important to realize that each one of these systems plays a really crucial role in our journey towards understanding how to grow food anywhere.
Okay.
From orbiting space stations to future settlements on Mars, this is the future of food.
Let's jump right in with a system I think that astronauts interact with most. Veggie. What is veggie?
So veggie is fascinating because it's all about providing astronauts with this direct connection to growing their own food. It's almost like a miniature self-contained garden right there on the International Space Station.
It's true. I read that they even get to eat what they grow. It's not just for experiments. It's can you imagine picking fresh lettuce in space?
And it's not even just about the taste. Having those splashes of color, things like zinnias, which they've grown in veggie, can be such a huge morale booster on those long missions.
Yeah. How interesting. So something as simple as a flower can have such a big impact. How do they even begin? I mean, doesn't everything just float away in microgravity?
Right. And that's where those plant pillows come in.
Plantos.
Yeah, so they've designed these special pillows. They're filled with this kind of clay-based growth media and fertilizer.
Interesting.
Provides everything the plants need to thrive.
So it's like a high-tech potting soil.
Exactly. And each pillow has this ingenious wick-based watering system.
Wow.
No risk of water floating away, and it ensures that the plants get a constant supply of moisture, just like those self-watering planters that we have in our homes.
Oh, interesting. Okay, that makes a lot of sense. So veggie is all about that hands-on astronaut-tended experience. But let's talk about its more automated cousin, the Advanced Plant Habitat, or APH. This one sounds seriously high-tech.
Yeah, you can think of APH as less of a garden and more of a plant science laboratory in space.
Ooh.
It's completely sealed, and it's remotely controlled by scientists on Earth.
Okay, so we're taking it up a notch. What kind of things are they studying in this space lab?
Well, APH allows them to really fine-tune every single aspect of the growing environment. Like they can play with different colors of light to see how it affects plant growth. They can even simulate Martian conditions.
Wow, Martian conditions, that's incredible. So it's not just about growing food in space, but using space to understand how to grow food better, even here on Earth.
Precisely. And one of those exciting aspects of APH is its use of hydroponics.
Hydroponics, now I've heard of this.
Yeah, so that's where plants are grown in this nutrient-rich water solution rather than soil.
So that sounds like something straight out of a sci-fi movie, but also super practical for space, right?
Absolutely. Think about it. Soil is heavy,
Yeah.
difficult to manage in space. Hydroponics offers this like lightweight and efficient alternative, not to mention incredibly resource efficient. We're talking using 90% less water compared to traditional agriculture.
Wow. And APH is already proving that this can work. It's successfully grown wheat and peppers.
It's happening.
It's not just a pipe dream, it's happening now.
Exactly. But before we get too far ahead of ourselves, dreaming of these Martian greenhouses,
Right.
we have to pay homage to the systems that paved the way.
Okay, I like that.
Right.
Yeah, I like that a lot.
Veggie and APH would not be possible without the pioneering work of these earlier systems. And that's where BPS comes in,
The BPS.
the biomass production system.
Okay, the BPS, the Biomass Production System.
It's a mouthful.
It is, it's a mouthful.
Yeah.
That sounds descriptive.
Yeah.
What exactly was its claim to fame in the world of space gardens?
It might not sound as glamorous as veggie,
Right.
but BPS was absolutely essential in those early days.
Okay.
It helped us understand the very basics of how plants develop and produce seeds in this unique environment of microgravity.
So kind of like laying the groundwork for everything that came after.
Exactly, and they learned so much from that system.
Like what?
For example, they discovered that plants in microgravity, they don't have the same cues from gravity to tell their roots which way to grow,
Oh, interesting.
which led to some really interesting growth patterns.
I bet that must have been fascinating to observe. And speaking of laying groundwork, I read that this wasn't just a solo mission for the U.S. The LADA greenhouse sounds like it was all about teamwork.
Absolutely. The LADA greenhouse was this fantastic example of international collaboration, a joint effort between Russia and the U.S. It really highlighted how much more we can achieve by working together.
Now, that's a cool message, especially when you think about how space exploration brings people together.
Right.
But in terms of the science, how was LADA different?
LADA was really interesting because it explored both soil-based and hydroponic growing methods.
Oh, cool.
Well, it gave us a chance to compare and contrast those approaches in a microgravity environment.
A real side-by-side comparison, huh? That's smart.
Yeah.
It seems like all these systems, from BPS and LADA to veggie and APH, were all about figuring out how to grow plants for food, but bioculture sounds different.
Yeah.
It's like we're suddenly zooming in on a whole other level.
You're right. Bioculture is this fascinating shift in perspective.
Okay.
It's less about growing a whole plant for food and more about understanding how individual plant cells behave in this kind of bizarre world of microgravity.
Okay, so less about lettuce, more about plant cell biology.
There you go.
It sounds like something out of a science fiction movie. Scientists huddled over microscopes watching plant cells tumbling through space.
I love it.
I know, right?
There's a certain poetic ring to it, isn't there?
Totally.
But in all seriousness, bioculture has helped answer some really fundamental questions.
Yeah, like what?
How does the lack of gravity affect a plant's growth at the cellular level?
Okay.
What about its stress responses? It's giving us this entirely new window into plant biology.
And a deeper understanding of how plants function, especially in extreme environments,
Right.
could be a game changer.
Right. You've hit the nail on the head, and that brings us to, I think, the bigger question.
Yeah.
The why
Mhm.
behind all of this.
Yep.
Why are we so invested in creating these space gardens?
Yeah.
It's about so much more than just keeping astronauts well fed.
Oh, right. We've covered some of it already.
Right.
But I'd love to dig deeper.
Yeah.
What are the biggest reasons these space gardens matter?
Okay.
Both for space exploration and for life here on Earth.
Well, for long-duration missions, we're talking about survival.
Okay.
Imagine a multi-year journey to Mars,
Right.
a planet with no grocery stores.
Right. Astronauts can't just order takeout.
Exactly. These systems become a crucial part of the life support system. Generating oxygen, scrubbing that carbon dioxide from the air, providing that source of fresh food, they're a vital part of creating this self-sustaining closed-loop ecosystem.
Closed-loop ecosystem sounds intense. Can you break that down a bit more? What does that actually mean?
It means creating a miniature version of Earth's natural cycles
Okay.
within the confines of a spacecraft or a future Martian base.
Wow.
Everything is interconnected.
Okay.
Plants consume carbon dioxide. They release oxygen, which the astronauts breathe.
Right.
And their waste products can even be used to fertilize the plants.
Wow, that's amazing.
It's about creating this sustainable, self-sufficient environment.
So we're talking about learning how to create little pockets of life support powered by plants. That could sustain us on other planets. It's like something straight out of science fiction, but it's happening now.
It's happening.
It's mind-blowing to think about it that way, We're talking about creating like mini Earths powered by plants out there in the vastness of space. But you mentioned something earlier that really stuck with me, the idea that these space gardens could help us tackle challenges here on Earth too.
Yeah.
Like climate change, for example.
Absolutely. The lessons we're learning from these space gardens have the potential to completely revolutionize agriculture.
Okay.
Right here on our own planet. Think about it. In space, you're forced to be resourceful, to use every last drop of water,
Right.
every bit of space, efficiently.
Yeah.
Those are skills that are becoming more and more important
Right.
as our climate changes.
Totally.
Our resources become more scarce.
It's like space exploration is forcing us to come up with solutions that we can then like bring back down to Earth.
Exactly. Take hydroponics, for example.
Uh-huh.
We already talked about how efficient it is in terms of water usage, but it also allows us to grow food in urban environments and vertical farms, even in areas with depleted soil.
Wow.
These are solutions that could help us feed a growing population in a changing world.
So space gardens aren't just about surviving in space, they're about thriving here on Earth too. And, it's not just about the hard science. We've talked about the psychological benefits for astronauts tending their own gardens. It makes me wonder, could that aspect be even more important than we realize?
It's a fascinating question.
Mm-hmm.
We know that, isolation and confinement, these can really take a toll on mental well-being.
Yeah.
And that's only going to be amplified on those long-duration missions to Mars and beyond.
Right.
Imagine having access to a little patch of green,
Yeah.
a place to connect with nature, even if it's just a simulated version of it.
Yeah.
It could make a world of difference.
It's like gardening could become an essential part of space therapy.
There you go.
Imagine tending to your plants, watching them grow, maybe even enjoying the aroma of fresh herbs.
Right.
It could be such a powerful way to combat the stresses of deep space travel.
And imagine the psychological impact of receiving fresh food grown by your loved ones back on Earth, millions of miles away.
Wow.
It could create this tangible link to home, a reminder that you're not alone,
Yeah.
in that vast expanse of space.
Wow. That's a really powerful image. It makes me think about space gardens in a whole new light. It's not just about the science and the technology, it's about the human element too.
Exactly, and that's what makes this whole field so fascinating. It's at the intersection of science and technology and the human spirit.
We've gone from space salads to sustainable farming to space therapy, all thanks to the incredible world of space gardens. It's amazing how something that seems like science fiction is actually paving the way for a more sustainable, hopeful future, both among the stars and right here on Earth.
I'm excited to see it unfold.
Me too. So if you had the chance to grow something in your own space garden, what would it be? It's something to ponder as we wrap up this deep dive into the amazing world of plants in space. Until next time, keep looking up.
Hi again. So, how was the deep dive? We discussed 5 different plant growth systems, starting with the veggie, and then the APH, BPS, the biomass production system, the LADA greenhouse, which was a Russian collaboration with the ISS and NASA, bioculture system, which technically is about studying plant biology at the cellular level. So it focuses on plant cell cultures rather than fully grown plants. And that is important too. So in this episode, we did a deep dive on the different plant growth systems that's on the ISS, or the International Space Station. Now, in the next episode, I'm just going to give you a little peek. We will be speaking about closed loop system. What is a closed loop system? And how is it important for growing in space? This is important, and there's a reason why I want to talk about plant growth systems before we speak about mushrooms. And the way we are going to bridge it is by understanding closed loop systems in space and why we have a need for a closed loop system in space. That'll be for the next episode. So until then, goodbye. Keep exploring.